Visit crow.academy for more tutorials.
Okay, welcome to this course that is an introduction to Java by Crow Academy. Okay, let's begin with the Java origins. The history of Java starts with the Green Team that was a Sun Microsystems team that has the mission to create and develop a language for digital devices such as set-top boxes and primarily for televisions. For that time, televisions have like low-profile hardware and will not run Java. However, it was suited for internet programming and some kind of applications with a lot of security concerns. The evolution then was unstoppable. Okay, what are the Java principles? Java foundations were to create a language simple and robust, portable, platform independent, secured, high performance, multi-threaded, architecture neutral, object oriented, interpreted, and dynamic. Why was Java created? Java was originally created for interactive television, but it was too advanced for the digital cable television industry at the time. Java promised write it once, run everywhere, anywhere, world, providing no-cost runtimes on popular platforms with priority on security and featuring configurable security. It allowed network and file access restrictions and a lot of security layers. Okay, so object-oriented programming core concepts are encapsulation, polymorphism, that means taking a lot of forms, abstraction, that means like abstract an idea or an object, and inheritance, that is like classes can only inherit from one parent. Abstraction is one of the key concepts of object-oriented programming. What is abstraction? Abstraction is the process of hiding the implementation details from the user. Only the functionality will be provided to the user. In Java, abstraction is achieved using abstract classes and interfaces. Okay, so let's see the differences between abstraction and encapsulation. Abstraction is a general concept formed by extracting common features from a specific examples or the act of withdrawing or removing something unnecessary. So you can define some interfaces and abstract classes, and you can reutilize them in a lot of classes. So it's very intelligent to use because you can write less code. So at the design level, it's very powerful. Otherwise, encapsulation is a mechanism that binds together code and the data it manipulates and keeps both safe from outside interface and misuse. You can implement encapsulation using the access modifiers like public, protected, and private. Encapsulation solves the problem in implementation level. So, abstraction is at the level of design level and implementation level is for encapsulation. For simplicity, encapsulation means hiding data using the getters and setters convention. The abstraction in object-oriented programming. Several ways to achieve abstraction in object-oriented programming are interfaces and abstract classes. So here you can see an example. For example, you have a button, and this button is a concrete class, and it has all the functionality of the abstract class, and also can implement this abstract class implements an interface. So it's very powerful. You can see an example. Interface. It's a collection of abstract methods. A class implements an interface, thereby inheriting the abstract methods of the interface. Along with abstract methods, an interface may also contain constants, default methods, static methods, and nested type. Method body exists only for default methods and static methods. Writing an interface is similar to writing a class, where a class describes the attributes and behaviors of an object, and an interface contains behaviors that a class implements. Interface properties. An interface is implicitly abstract. You do not need to use the abstract keyword while declaring an interface. Each method in an interface is also implicitly abstract, so the abstract keyword is not needed. Methods in an interface are implicitly public. So here we can see a basic example of an interface. You have like an animal.java file and an interface with the name animal, and has two methods, two abstract methods that must be implemented for the class that implements this interface. These methods are mandatory. Here we can see like the Java interface is a relationship. So we can see that Java inheritance is a relationship. Is a relationship with animal is a cat. Is a, and is like, and you use the extend keyword. Extends keyword. So cat extends from animal. Animal extends from superclass. And if you continue, the root class, the parent class is object. Subclass and superclass are the two main. Superclass, animal, and subclass is cat. Inheritance with access modifiers, no multiple inheritance. You can only inherit from one superclass. Typecasting, you can convert a cat. An object cat instantiated into an animal is called upcasting. And you can also convert an animal into a cat with downcasting, but it's dangerous. If there's a mistake in the implementation, it can cause a runtime error. You can also override methods, call superclass method, instantiate instance of instruction, fields and inheritance, constructors and inheritance, nested classes and inheritance. Object class in Java. Object class is present in the java.lang package. Every class in Java is directly or indirectly derived from the object class. If a class does not extend any other class, then it's directly class of object and extends other class, then it's an indirectly derived. Therefore, the object class methods are available to all Java classes. Hence, object class acts as a root inheritance hierarchy in any Java program.
Microvirus for elements of largest scientific blockchain.
Class object. The class object forms the root of the overall inheritance tree of all Java classes. So the object class has like the basic functionality that any object should have according to the Java developers. So Java creators, James Gosling and the subsequent creators. So the object main methods are like these equals. You can compare two objects. You can finalize. You can destroy the object by garbage collector. This is can be done automatically. You can get the class of the object. You can hash code the object. You can notify all, or convert the object to a string, an object to, in order to print it in a console. The object class defines several methods that become part of every class you write. For example, public string to string returns a text representation of the object, usually so that it can be printed. What are the common properties of objects? When soon designed Java, they felt that every object, including arrays, should be able to be compared, equals, be printed to string. Ask questions about the runtime about the type of class, you can get the class. Be created via constructors, copied, cloned, and destroyed, finalized. Be used in hash code collections with hash code, or perform multi-threaded synchronization and locking, notify wait. This powerful and broad set of capabilities help Java adoption as an object-oriented language. So here we can see the main object methods. For example, clone creates a copy of the object in a specific timestamp. Equals compares two objects and returns a boolean true or false if the objects are the same. You can also finalize an object. You can get the class, info about the object type. You can hash code the object, So a code suitable for putting this object into a hash collection, and you can put it to string text representation of the object. And this also notify, oh, wait, are methods related to concurrency and locking. We will see later. So here we can see like the object class, that is the root, the parent of all other classes in Java. So you can see here what one of the Java language official classes, like math class, character class, boolean, number. Yes, in the number has subclasses like integer subclass, long subclass, float, double subclass. Okay. So let's see an example. Like let's see the Java's math class. It has some methods that are the more used methods. For example, math apps returns the absolute value. It removes the sign. Math.seal rounds up the number. If it has decimals, for example, 7.6, it rounds it to 8. Math floor rounds down. For example, you have 3.2, it downs to 3. Math.log 10, logarithm base 10. If you use max, it compares two values and it returns the max value. Math.min, the method min, returns the mean value of the two values compared. The math.power, you give it a base and an exponent. So the base to the exponent power is the return number. Math.random is a semi-true random because you know that random is not possible, but it returns a possible random number. That works very fine for creating a random experience. And math round, nearest whole number. If you have like 3.6, the nearest whole number is 4. Math squared, the square root. Also, you have the sine, cosine, and tangent of an angle in radians, and you can also map to degrees. You can convert the radians to degrees or vice versa, the degrees to radians. So here we can see the number class in Java, 1.8. And for general calculation, like for an application or something like that, you can use byte, integer, long, short, double. But if you're developing like a very precise robot or machine, you can use the big decimal or big integer for scientific purpose. And also you have the multi-threaded application, atomic integer and atomic long. Okay, so here we can see the Java class, the big decimal. Big decimal extends from number, and number extends from object. This is the superclass of number, number is the superclass of big decimal. And big decimal also implements these two interfaces, serializable and comparable. So we can see in serialization, Java provides a mechanism called object serialization, where an object can be represented as a sequence of bytes that includes the object's data as well as information about the object's type and the types of data stored in the object. After a serialized object has been written into a file, it can be read from the file and deserialized, that is the type of information and bytes that represent the object and its data. It can be used to recreate the object in memory. Most impressive is that the entire process is JVM independent, meaning an object can be serialized on one platform. For example, you can create an object serialized like in Windows, and then it can be read deserialized on an Android. So it's very powerful. What are the requirements for serialization? To allow an object to be serializable, its class should implement the serializable interface. Its class should also provide a default constructor, a constructor with no arguments. Serializability is inherited. Don't have to implement serializable on every class. and just implement serializable ones along the class hierarchy. Okay, we also want to cover the Java constructor concept, and the constructor is when you instantiate an object, when an object is created, and you know that typically you will use a constructor to give initial values to the instance variables defined by the class or to perform any other startup procedure required to create a fully formed object. All classes have constructors, whether you define one or not, because Java automatically provides a default constructor that initializes all member variables to 0. However, once you define your own constructor, the default constructor is no longer used. So here we can see the difference between constructors and methods. So a constructor is used to initialize the state of an object, and a method is used to expose the behavior. A constructor must not have a return type, and a method must have a return type. The constructor is invoked implicitly, and the method is invoked explicitly. The Java compiler provides a default constructor if you don't have any constructor in the class. The method is not provided by the compiler in any case, and the constructor name must be same as the class name, and the method name may not be the same as the class name. So, returning to the concept of packages, here we are seeing the Java util package. That is, this package is included in Java 1.8. You can see here the java.lang language package has the class, the object, string, thread, and you can see other packages like Java util, Java input output stream, java.net, Java applet, etc. What is the purpose of a package? The purpose of a package concept is to provide common classes and interfaces for any program separately. In other words, if we want to develop any class or interface which is common for most of Java programs, that such common classes and interfaces must be placed in the package. Package advantages. Package is used to categorize the classes and interfaces so that they can be easily maintained. Application development time is less because you reuse the code. Application memory space is less, main memory. Application execution time is less. Application performance is improved. Redundancy repetition code is minimized. Package provides access protection. So here we can see like the Java util package that is included in Java 1.8. Here we can see like the superclass collection. It extends from iterable, and for example, these are two common classes in Java, list and set. And this is a very popular class, array list, linked list, vector, hash set, linked hash set. They are very used in Android Studio. In developing applications, they are very common for great development. We are also going to see the Java input-output package that is included also. It contains nearly every class you might ever need to perform input and output streams in Java. This package is not included in Android. Android Studio and Google developed its own package for writing files. All these streams represent an input source and output destination. The stream in the Java I/O package supports many data, such as primitives, objects, localized characters, etc. Reading and writing files in Java. So here we can see, like if you write an application for Windows or for Linux or for Mac, you can use input stream for reading files and output stream for writing files. So you can like file input stream, read a file, and you can also file, if you create a file, like a text file, you can file output stream and write it in your computer. Okay, let's continue with the object-oriented programming core concepts. We are seeing now polymorphism that has two main branches, that is overloading and overriding. Overloading methods is where more than one method share the same name with different parameters or signature and different return type. We're going to see an example. And overriding methods of superclass by methods of shell class, which is done by the Java virtual machine. So for example, method overloading. You can, for example, if you want to add numbers, you can overload the method add. Here, if you want to add two numbers, this is like the bad implementation way. You can create a method called add and give it two parameters, two integers to be added. But you can overload the method and you can pass three integers. So you can have three numbers. This is the correct way doing Java, and this is not a good practice. You need to use method overloading. Now let's see method overriding. For example, if you have an animal, a robotic animal, an animal can move, but you have a dog also, and a dog extends from animal and also move, but a dog moves different than, for example, for a dolphin or a blue whale. So a dog has its own move method. This is called overriding method. So when you instantiate a dog and you call the method move, the dog will move as a dog, not as a generic animal. So this is overriding the method. You override it in dog. And the last very important core concept for oriented programming is encapsulation. That this means to protect the information. It's also data hiding. It's a field is declared private. It cannot be accessed by anyone outside the class, thereby hiding the fields within the class. For this reason, encapsulation is also referred as data hiding. So it's very important, this concept, because you can hide a lot of primitive data types, a lot of variables. You can hide it, and you can only, for example, ATM card can access the ATM machine, but can only access some very short list of methods and cannot access any other information and variables. To be continued. Thanks for seeing this video, and please subscribe. And